So analog to digital conversion is basically two steps: sampling and quantization. Um, so first we have to discuss about the sampling. Quantization we will see in next video. So sampling is a process of recording the values of a signal given point in time. So ABD converters, these points in times are equidistant. So number of samples taken during 1 second is called a sample rate. Okay, that time and gain m. So time t and gain m. So this is continuous time signal and this one is discrete time signal. So this is sampling, the process of measuring the instantaneous values of continuous time signal in discrete time. So sample is a piece of data taken from the whole data, that is called a sample. So this is a continuous in time diamond. So when a source generate analog signal, if it has digitized having ones and zero. So here the following figure continuous time signal x and t and sample the signal x on t. So this is continuous time signal and this one is sample the signal for that continuous time signal. So they are taking the samples from these signals. So this is sampling rate. So what is sampling rate? So sampling rate, it's a sample should be fixed to the gap to be terminated as a sample period ts. So sampling frequency. So sampling frequency can be simplified by calling sampling rate. So sampling rate is denoted as samples taken per seconds. That is called as sampling rate. Okay. Uh, so sampling rate is nothing but how many samples taken within the second. Nyquist rate as a formula is a higher. What is Nyquist rate? The formula, the highest frequency and the sampling rate Fs is equal to 2W. So the sampling rate is equal to 2W, twice the highest frequency. That is Nyquist rate. So sampling frequency rate and W means highest frequency. That should be twice the highest frequency. This is the rate of sampling is called this rate of sampling is called Nyquist rate. So yeah. So sampling theorem. So sampling theorem, which is also called as a Nyquist theorem. So here the sampling theorem they have for sampling frequency greater than twice the maximum frequency. To understand this sampling theorem, so we have to follow the three steps we have to follow. So, so the step one, the sampling frequency rate is higher rate than twice the frequency. So the frequency domain will be like that. They have the gap between that information. So there is no loss between the information because the when you go into reconstruction, then recovery is possible because the gap is there, so there is no loss of information. Here, it's a good sampling rate without loss, but the sampling frequency is equal to twice the highest frequency. So previously greater than highest frequency. So if it is equal to highest frequency, so the information will be look like this. So here also there is no loss, then there is no problem. But this condition, the frank sampling frequency is less than twice the highest frequency. So if the sampling frequency is less than twice the highest frequency, we have the intersection between the information. So automatically the information getting lost. So this is called as aliasing or overlapping. So this overlapping we can call as a aliasing. So this is nothing but aliasing effect or aliasing. So for avoiding this aliasing, we are using low pass sampling, low pass filter. So uh, this aliasing can be referred as a phenomena of the high frequency component in the spectrum of the signal. So the aliasing effect max phenomena is high frequency component in the spectrum of the signal. So identify this. We have to use low frequency component filter, that is low pass filter or anti-aliasing filter. So you have to present that low pass filter, anti-aliasing filter placed or employed in the filter before we have to modulate or convert our analog to digital. So before that we have to place that anti-aliasing filter. So then the highest high frequency components are eliminated by low pass filter. So the aliasing effect will be prevented by this anti-aliasing filter. And finally we can reconstruction when completed analog to digital, digital to analog conversion. Finally the reconstruction filter will be getting good rate in okay, sampling sampled values for sampling interval. Optimum sample depends upon the maximum frequency component present in the signal. So this is sampling and sampling interval, and quantization, that is we will discuss in next video.